All right, now let me try. Oops. Okay. Then how about this? How about that now? Can you see?
Yes,
Can you
we
see
can
it?
see that. Yeah,
Yes,
yeah.
I can see now very clear. Yes.
Okay. So now we have here the lab manual. Remember, so if you will have your book with you, so you'll find this circuit, figure 7.1 and figure 7.2. We have two circuits here that we need to experiment. So also we have tables, which is okay. So for table 7.1, so this should be completed using figure 7.1, and for table 7.2, this one, so this will be completed using the figure on or using figure 7.2 as well. All
Mm-hmm.
right, now for table 7.1, as you can see, you need to look for the voltage. So as you can see from the top, okay, voltage. All right, you have to take the voltage, VA, VB, VC, and VD. All right, so you have to look for these voltages, and for figure 7.2 or table 7.2, you need to take the current. So for R1, the current through R1, R2, R4, and what's that? R6. Okay, the giga. Okay, so sorry. So 7.1 and 7.2. Okay, wait. So there's a correction here. 7.1 and 7.2 will be for figure 7. The first figure, the first diagram. This one, figure 7.1. So there are two tables for 7.1 circuit. There will be two tables, this one and this one. And this third table 7.3, would be for this figure, this one, 7.2. Okay? Clear?
Yes, sir.
Hello?
Clear, clear.
Okay. Now, let's start by constructing. So what I will do now, I will construct a circuit using the multisim, okay, to take or to get the value of VA, BB, BC, BD, as well as current R1, okay, R1, R2, R3, and sorry, R4 and R6. So this is what he needs, okay, complete this table. So you'll put your numbers here. Sorry, you can put your numbers here as because since this is a simulation, all right, it can be, so the data coming from the simulation can be written, oh no, sorry, in the measured, okay, in the measured, okay, in the measured values, all right, okay. So let me try now to create a circuit. So since, oh, sorry, all right, okay. So let's now try to create the circuit using this, okay, this program. All right. So as you can see, if you try to, okay, to try to look on the video that I had before uploaded in the YouTube on the channel. So I have instructions there on how to use the program to construct a circuit. Okay. So in this case, let's try to construct the circuit. What's this circuit? Figure 7.1. Let's try to construct this circuit using this program. So what we need is how many resistor? One, R1, R2, R3, R4, R5, and R6. And what's the value of these resistors? Where's those value? Oh, this one, 1 kilo, 2.2 here. Here's the value. All right, and that's the source. Okay, for figure 1, 7.1, we have R1, 1 kilo, R2, 2.2, R3 is 3.3 kilo. Then we have R4, 6.8, R5, 10 kilo, then R6, 22 kilo. So we have a source of 20 volts. So what you will do, same thing as I did in the video. You need to take first all this, so you have to look for this toolbars here on the side, okay, and take the components from these toolbars. So like for example here, so you need resistors, all right. So we need resistors. Let's try to, okay, that we can see the circuit at the same time. Okay, so let's try to construct. Okay, so let's have the resistor. First resistor we have here. We need the first resistor. Then that's R1. Then let's have R2. So duplicate. Alright. So click this tool. Okay. Click that icon. Then put R2 here on this side. Let, let me move this one first. Here, this side. Okay. So we have R2 there. R2. So we have to rotate it. R2. Okay. By clicking this button, you can rotate the position of the resistor. Then let's again copy duplicate for R3. So we need R3 here on the top. Okay. Then let's rotate it again for R3. Reposition it. Okay. So you can drag also to reposition. Okay. Position the change the position of the resistor. Then we have one more here, R4. Alright. Rotate. Okay. Then we have R5 here. Let's put R5 here. This. Okay. Then rotate again. This button will rotate it. Okay, then another copy, so you need to duplicate another one, R6. Okay, here can be R6, can be here, this part. Okay, rotate again. So we have now all the 6 resistors. All right. Then also we need the, what you call that, the source, which is the battery source. So we can, so go back at the toolbars here on the side. So click on this button, sources. So from there you find the battery DC voltage. Click that one, and then it will be there. All right. So the next thing, don't forget to again put the ground. So there should be ground, always ground. There should always be a ground connection on the circuit. So the ground came from here, from this toolbar. All right. Now, so the next thing is to connect. Oh, sorry. Before connecting, you must change the value, the needed value, because the values of resistors are different from each other. So like for example, R1, we have R1, that should be 1K, okay, it's done. 1K is there. How about R2? R2 should be here, see? R2 should be 2.2 kilos. So what you need to do, only double click R2, okay? So, and change it from here. So that would be 2 points. So you have to put 2.2 kilo. Then click the window here, all right? Then R3, how much R3? 3.3. So we have here 3.3 kilo. Then click again the window here. It's done. 3.3 is there. R4 is 6.8. Okay, R4 6.8. 6.8. Can you follow? Hello. Are you there?
Yes, yes, Doctor, yes. We follow you. We
Are,
follow you.
can
Yes,
you follow? Can you follow? Are you following?
yes, yes.
Yeah, yeah.
Okay, R5 we have how much? 10 kilo. Yes. put 10 kilo, 10 kilo there. Then click the window here. Then we have R6. So R6 should be 22 kilo. R6 should be, okay, 22 kilo. Okay, there, R6 22 kilo. 22 kilo. Okay, so that completes the resistor's value. Now we go to the source, which is E here. We have E value here. All right. So that's 20 volts. So that's the source. So we can change the value from here also 20 volts. We put 20 here. Then that's it. So now let's complete the values of the source and plus the resistors. All right. So the next thing is to just connect it. Connect. Okay. Connect the circuit together to complete the circuit. So let me close this one so that we can see the, okay, right now. So again, how to connect the circuit. So again, okay, from the video, I show you how to connect the circuit. So the first thing is you need to point the mouse on the connecting point or the terminal point of the, see, if you see that symbol, left click, okay, then going there, left click again to end the connection. Okay, next, again here, just point, okay, once you see that symbol, connect it there, okay, sorry, connect it there, left click to end the connection. Again, okay, that's it. So, sorry, okay, it's connecting. Okay, so next, this one goes here, sorry, goes here, then this point goes there, then this point, where is it? Yeah, where is it? Okay, this point, or sorry, so whether here, okay, this point going here, then we have here this point going to that point, then we have here now this point going there up, and this one going to that point up. So now that completes the circuit. So that's figure 7.1. Okay. So next thing, what? We need to put, what do we need in the table? What do we need in the table? We need voltage VA. Where's VA? This was VA. This is VA. A, B, C, and D. For the circuit, you will find letters, no? A, B, C, and D. So this means that this is voltage VA, point VA. Okay. This is point VB, voltage VB. This one, voltage VC. And this one is voltage VD. Alright. So very simple. All you need to do is only to connect the multimeter or the measuring instrument across each point to measure these voltages VA, BB, BC, and BD. So what you will do, again, go to this toolbars. All right, then here from this analysis and annotation, you find here, okay, the instrument that you need, like for example, measuring voltage, current, voltage and current at the same time. This one will measure the voltage and current at the same time. Digital also, digital probe. All right. So, but for this thing, we need to only measure first VA. So let's use this one, this instrument V. Okay, and put the, all right, put the instrument, okay, at point A of the circuit. All right. So meaning this one will measure. You can change the ID or the label, which is VA. So that's for VA. So this will measure VA. Another one, B, point B. So this is point B here. All right. So this one will measure BB. Okay. Then we have here VC, this point C here. So we have here BC, BC. Then the last one, BD here, this point. This point will be BD. All right. So BD. Sorry. BD. Okay. So we have now all the needed connection for measuring the voltages. All right. Can you follow? Hello.
Yes, yes, doctor.
Okay, so we have VA, VB, BC, and BD. Now next, we need what we need to measure. Huh? From the table, what we need? We need current. See here, we need the currents for R1, R2, R3, and R4. All right. So where is that one? We need the current for R1 here. The current flowing here in this resistor. R2, R4 here. This part and R6 here. So we need the current here. Again, R1 here. This part is the tarik, the line. R1. We have here R2, this point. R4 is this. Okay. This tarik or this line, spot. And this one is R6. Okay. So what I need to do, very simple again here. Go there on the toolbars. So we need current measurement. So just click this one. Click this button on toolbar. So we need to measure current. So here, from this point, we can measure current R1. Okay, that's so let's call it I. Let's try to call it IR1. Okay, IR1. IR1. All right. So next, is that correct? IR1. Yeah. Is it there? Okay, IR1 is there. Next we have IR2. Let's do where's IR2. So yeah, IR2 here. This point is IR2. So we can also do it's either here, okay, this point, or you can put it also in this point as you like. Okay, because it will cover this part. So I just put it here along this line. But we can transfer it if you want. Sorry, sorry. Yeah, we can transfer it here, but the problem it will cover. Oh no, it's okay. So let's call it IR2. 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 All right. IR2. So sorry. Better I think put it IR2 this way. IR2. Is that all right? IR2. Okay. Then we have here this one. Let's change it to IR1. IR1. That's it. Okay, IR1. So we have IR1, we have IR2. What we need? IR4. So here, along this path, is IR4. So let's put a measuring instrument here for the current. Okay, we will call it IR4. Then the last part we have here IR6. So we need to measure IR6. So from this point, okay. So this one would be IR6. Okay. So I think that's complete the circuit now. It's complete. All right. So here again. let's try to review the circuit. So we need BA, okay? BA, BB, BC, BD. So that's BA, point BB, point BC, and point BD. As well as the current now here, we have the current. So current here, IR1, that would be IR1, sorry, here, IR1, this one, IR2, along R2, or yeah, the current through R2. Then we have IR4, the current through R4, and then we have R6, the current through R6. All right. So again, don't forget to connect this one, the ground connection, because again, it will have an error. If you simulate the circuit without this ground connection, you will have an error. So you have to put a ground connection. Even though, yeah, as you can see, even in the circuit, you know, it's showing the connection for the ground. This one, okay? For a moment. All right, let's connect this one, okay? Ground connection to the circuit. Okay, so that now completes the circuit for figure 7.1. Okay, and from this point now you can simulate now the circuit to see the results, to see the values of those voltages and those currents. All right, so by clicking, okay, this button, okay, see this shows run simulation. Okay, by clicking this button, you will find the results of all the voltages and the currents that you are measuring and you are trying to measure. So click it. Let's see. All right, now, so that's the results. All right, so we have VA as 20 volt. We have V2 here, 12.76. BC is, sorry, BA is 20. BB is 12.76. BC is 8.03, BD is 5.5. So as well as the current here, we have 7.23 milliampere IR1, IR2 1.43, IR4 251.13 micro. Okay, that's microampere, or also same as 0.25 milliampere. Same as this one, which is 251.13. What? Why the same current? IR4 is the same as IR6. Same value. Any comment? Hello? Hello?
Yes, doctor. What you say
Yes,
again?
Any
doctor.
comment? Any comment? IR4 and IR6 is the same. 251 point micro. 2.51 251.13 microampere. Why?
Um, I
Why is the
don't know.
same current?
Doctor, IR6 it's not available, and IR4 it's 1.18 milliampere.
1 point come?
1.18 milliampere.
Which one?
IR4.
Really?
Yes.
Why it shows here 251? Same with 2
Teacher,
IR6. Yes.
R4 and R6 is the same current because it's parallel.
The giga. What's the value of la la ya Sheikh? What is this? Why like this? Is it possible? What's the value of IR? What's the value of IR R5? R5 is 10.
Yes.
R6 is 22. series, and R4 is 6.8. How come it's the same? I think there's something wrong here. Why is the same? IR4 and IR6 are same. How come? Why? So the I total here. So we have the current the IR4, IR6, 251, exactly the same. 251.13 micro ampere. So we have 20, 12, 8, and 5. Yeah. The voltage are correct. VA, VB, VC, and VD are correct. Seems to be correct. But I doubt the current. The current 7.2, we have 1.4, 251.13 microampere. Okay. So, but this is simulation. It cannot be wrong. This should be correct. Unless we connect. But the connection is correct. We are measuring IR4 here on the side. IR4, IR6 here on the side. The current here should be split here in two ways. We have node here, node C, should be split by. Why is it the same? Why is it the same? Since the resistor is 22 and I go on that 22, can I stop and simulate it again? Let me see. Yeah, it's the same, really the same. What is this value? Let me see. What is this value? 10 kilo. Then we have 22 kilo. Yeah, it's 10 kilo and 22 kilo here. Then we have 6.8 R3, R4. Wow. Okay. I think, okay, just put your, because I don't have the manual with me. Let me check the manual and let me check my values. Uh, Give me a while. I will get my manual. Okay. Let me see the the values if it's really true. 251 because I doubt this too. How come this becomes 251 IR4 and IR6 become the same? 251.13 microampere. Let me see the calculations there. Hello?
Yes,
Hello? So I think there's something wrong. See, that's why I doubt it. IR4 should be around 1 point something. So why we are getting 251? You know something here? I think there's something wrong here. How come? 2.8, 2.2. This one should be 1 point something. I think there's something wrong. I need to troubleshoot this one. So what do we have here? Let's check this one. Take it out. Then why this okay? IR6 251.13, that's true. But this one, how come? Why? Maybe we didn't connect properly. So let's try again to simulate it. So this will be. Oh, now it's coming. Oh, I think there's some issue on the. See, there's some issue on the connection. Okay, the previous connection that we did. Now it's coming. 1.18. See.
yes, yes, doctor.
All right. So this IR again IR4. All right.
Mhm.
So IR4. All right. That should be the case. I don't know what happened. Why before it was 2 point because I observed it. See, I already saw the problem. Okay. That's why I'm wondering why this current are the same on this current, which should not be the case. Do you agree?
Yes.
Do you agree? Because it will split here. Okay.
Mhm.
There's a node C here. The current will split here. And why does it be the same before? The same before it came the same before to 51.30, which should not be the case because you have different values of resistors. R4, R5, and R6 are all different. So how can you be okay? How can you get the same current for IR4 and IR6? It's not true. Now this is the real case. All right. So in this case, now this one is correct. Okay. So that should be the case. BA will be 20. B2 again. BB will be 12.76. As you can see. Oh, sorry. All right. BB here. Then BC is 8.03. BD would be 5.5.
Yes.
I, IR1 should be 7.2 milliampere.
Yes.
IR2 would be 1.4. Let me check in my book. 1.4.
Mm,
Oops.
doctor, IR2 5.8 milliampere.
Yes, yes, yes. Yeah. Again, a mistake, right? Wrong. Why? Okay, so there's something wrong in here. So 5.8. My calculation, I got it 5.8. So here, why is it 1.4? So you need, I think, because of the connection. Let's try to take it out. There's some issue in the connection when we did the connection here. So yeah, I should show you this one. That shows first. Okay, that signal should show first when you connect the measurements. Okay,
Mhm.
it's like a circle blinking. Okay, so once you see it's blinking, that means that it is the right path. All right. So let's try to rename it again as IR2. IR2. All right. And let's try to simulate it again. Simulate it again. Let's see. Okay, now it's right. So, Alison?
Yes, doctor. It's right.
Okay, now it's
5.8.
good. Everything is good. So let me see. Let me check in my book. In my book, my calculations in my book. Okay. Last time we have I total, which is 7.2, right? Which is I1. Minus I1. We have IR2, 5.8, right? Correct. So we have IR4, 1.18, correct? So we have IR6, which is 0.25 milli or 251 micro. All right, that's correct. So now let's see the voltages. So VA we have 20. In my book it's 20. So VB 12.76. which is correct. Let me see. Yes, correct. My calculation, the same. We have DC 8.03, that's correct also, and VD 5.5. Yes, that's correct. So everything now is correct here. So all of these measurements now are correct. So I think what we did, what error that we did before maybe the error is I connect the current, okay, without looking at the signal, okay, that circular signal that is showing that that's the right point of the connection already. So that's how it is. So anyway, you can check. That's why you see you have the calculation. All right, in your table, as you can see in your table, we have here two parts. The theory means the calculated value here. Okay, we have the measured value here. So measured value is this one. Okay, so these numbers are the measured value here. You have to put the numbers here. All right, at this
Okay.
column. Okay, and for as well as the current in this column also. Measured current here. So after that, try to calculate it using Ohm's law or what else? You can use divider rule as well if you want. All right. So Ohm's law or divider rule, it's enough for this circuit. And after calculating it, write the answers here on this column. So this is for the theory. Theory means the calculated value here. Then theory here, and then for the current as well here. Okay. So after you complete this table, what's deviation? Deviation is only the difference, okay? The difference between cal the theory or calculated value and the measured value. That's the deviation, the difference only. You got the point? You got it?
Yes, yes, doctor.
Hello, hello. Deviation, huh?
Yes.
Deviation is the difference between the theory value or the calculated value minus the measured value. All right?
Yes.
Okay. So any question? Is this clear? All right. Anyway, I have a recording. I will upload this also in the channel. Okay. I will upload this. I will try to upload this video on the channel. All right. Hello.
Okay.
Okay. So that you can watch it and review it. All right. Okay. So that's for figure. So we are done with figure 7.1. And that's table 7.1, 7.2. That completes these two tables for this circuit. All right. Then the next one, we have this one. Very simple. Table 7.3 is all about figure 7.2. This figure. So again, so what we will do? Let's see. Let's try to okay. Let's try to create another circuit. All right. Let's create another circuit. So what shall we do here? Again, okay, let's go out. Okay, new, what's this? Sorry, save. No, I will not save it. Discard it. Okay, so let's do another circuit, which is figure 7.2, and do the next table. Okay, so I'll make it quick. So let's have these resistors. So we have four resistors. One, copy. We have second resistor here. Then we have, oh sorry, should be here. Sorry, should be here. R2 is here, the side. Then R3 here would be here. So this will be R2. Sorry, this will be R3. Okay. So this will be R2 here. Okay. So here. Then we have to rotate it. Again, rotate here. Rotate. This one, rotate. Also, rotate. So R4, rotate. Then after rotating it, so realign it. Okay. So let's realign the circuit. So let's put here. Yeah, that one here. Okay. So we have the source. What's the source value for 7.2? So here, this is for 7.2. So for 7.2, we have here R1, then 10 volts. Okay, R1 1 kilo, R2 2.2, R3 10 kilo, then R4 is 6.8. Alright, so then we have the source 10 volts. So again, the source, let's do the source here. Get the source from the side. Alright, so now let's change the value. R1 should be 1 kilo. Okay, that's it. We have 1 kilo there already. How about R2? R2 we should be 10 kilo. R2 10 kilo. Then we have R3. R3 should be 6.8. Then R4 should be sorry. R3 should be no R2. Oh sorry. R1 should be 1 kilo. Okay, wrong. So we have something wrong here. Something is wrong here. So let's try to make it clear here. R1 should be 1 kilo. Yeah, that's correct. R2 should be 2.2 kilo. This should be 2.2. Sorry. This should be 2.2 kilo. R3 should be R3 should be 10 kilo. R3 should be 10 kilo. This should be 10 kilo. Then R4 should be 6.8. 6.8. 6.8 kilo. Right? Then we have a source of 10 volts. 10 volts. This one should be this battery of this source should be 10 volts. Alright. So that's complete the circuit again. Okay, that completes the circuit again. So we have those values there. Alright. Now let's connect the circuit now. Okay. So connect the circuit now. Okay, then this one connect it there, then this one goes there, and this one goes here. Sorry, goes here. This one goes to this point. This one goes to this point. Okay, then this one goes to this point. All right. Okay. So what do we need? We need VA. Okay. So we need the measured value for VA, BB, and BAB. Where's that? So this is the value for VA. So that's point VA. Then this is voltage BB. And for voltage BAB, this should be this point measured on this other point. That's BAB. Okay. Let's first measure VA. So let's try to put the measuring instrument to measure VA. Where is that again? Here. So let's have this V. This one will be okay. This will be VA. All right. Let's put here VA. Then we have here next. Let's measure BB. This point will be BB. All right. BB. How about BAB? Don't forget. By the way, don't forget this one, huh? The ground again. So you missed the ground. So you almost forget the ground. So don't forget the ground connection. All right. Now how about VAV? To measure VAV, okay, this should be this way. So use the voltage reference at this point. So put a reference voltage here. Okay. This is how to measure VAV. All right. Reference and okay. The reference will be that one. All right. Then so let's try to measure here. Okay. So as you can see here, we have the ground, no, reference one. Okay, reference one. So we have here, so you have to change this one. So this voltage will measure a voltage in reference to this point. That's what it means. Not in reference to ground, not this one, but here. Not this point, but this point. Okay, this is the reference point for measuring these voltages. So that would be VAB. So this should be having the voltage VAB. All right, is that correct? Okay. So let's try again to simulate the circuit. All right, let's see if it works. Okay, let's see. So this should be the value. This one VA value should be 6.8. VB is 4.04. Then this one, this is VAV, which is 2.8. Let's see in my book. It's the same thing. It's the same. 6.8. Yeah, 4.04. All right, 6.8, 2.8. Yeah, that's correct. So this is correct. All right. Hello. Hello.
Yes, doctor, yes. Correct.
Yeah, this is the correct numbers. These are the correct numbers. Okay. Again, this is VA 6.8. VB is 4.04. Then we have VAB 2.8. 2 volts. So that would be the results for this circuit. And that is the result here on this table. Okay. 7.3 table, measured value will be here. So here it will be 6.87, VB is 4.04, then VAB is 2.82. So how to calculate it? If you try to calculate it again using the Ohm's law or using Ohm's law or divider rule, so also write the values here. Then after completing these two columns, deviation again is the difference between the theory and measured value or the calculated value uh, with the measured value. The difference between the two would be the deviation. Okay. All right. So that completes the measuring for these two circuits. So it's up to you now to calculate these things, okay, and put the data based on your calculation using this column. You have to fill up these columns. So these numbers are for again for these columns measured value only, yeah, measured value here, okay. Then and anyway
So,
we will try to yes anyway we'll try to show you also. I will try to show you how to do the calculation. But if you cannot find the values, okay, if you have questions on how to get the values, you can ask me next meeting during our face-to-face meeting. Okay, but for the meantime, you can also try to calculate it using your methods. Okay, but those numbers now that I gave you now, showing this multi-sim program, those are the measured value now. No? Those should be the measured value that you should get, okay, for these two circuits. Any
Okay,
question?
I have question.
Yes,
VIB دكتور it's minus 2.8 volt.
yes, yes,
Oh,
yes, yes. Minus two
okay,
point eight. No, it
okay.
can actually. Who's this? Al Hassan.
Yes,
Al Hassan.
yes
Al
دكتور.
Hassan.
Yes.
Al Hassan. Actually, this can be a negative or positive values depending on the position of the probe.
Mhm.
Okay,
Okay.
negative because it's opposite. Okay, we can interchange the position. If you want a a positive value, just interchange the probe,
Yes.
the connection, interchange the position of the connection or the
Mhm.
probe, interchange it, and you will get a positive value.
Okay.
That's the only difference. But the same number will be there. Same number will be it will be the same number.
Yes, yes.
It depends on the position of the probe, the connecting, the probe connection, the multimeter or the instrument connection, the
Mhm.
probe connection. All right, but
Okay.
the numbers are good. These numbers are good. I check
Okay.
it with my calculation.
Uh-huh.
Okay.
Okay.
Any other
Okay.
question? Any
No.
other question? Okay. So
Okay.
if you don't have any questions, I think that would be the 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 discussion for today. All right. So I will try to upload this video again in the YouTube channel so you can review it. All right.
Okay. Okay. Thank you.
Okay.
Okay.
Okay. Thank you so much. Okay. Thank you so much, and I'll see you next meeting. I hope it will be face to face next meeting. All right.
Okay, but doctor, I have a
Okay.
question. Did
Thank
you
you.
recording the lecture?
Yes, I record this one, and I will upload it in the YouTube channel. Okay.
Okay, thank you so much, doctor.
No problem. You can review it there from there or from this from the channel. All right. Okay. How about Badrun? Badrun, where is Mr. Badrun?
Yes, teacher, I'm okay.
Okay, you're quiet.